On this problem, we will determine if a function is even, odd, or neither using the definition, meaning algebraically. So by definition, an even function is where we substitute negative x into x, we will get back the original function. And the opposite, if we have an opposite to that, it is where we have an odd function. The difference, of course, is just this minus sign. There's some example to that. Is for an even function, pretty much anything that to an even function is going to be even. A constant is considered to be even, and absolute values of x is also even. Example of an odd function, there's not much. We just x to the odd power, and then an odd root of x, but that will be enough. Right, now we use the definition to do this. The definition always starts with f of negative x, and that's where we start, f of negative x. So first, I will put negative x into x. Replace negative x to x, and that's what we have. So negative x to an odd power, that's the green negative signs. So this will be negative 2 x cubed, negative, and negative, that's the plus 5x plus 2. Now we compare this to the original function, and they're not the same because here we have 2x squared, negative 2x squared. So it is not the original function, meaning it is not even. Right. Next we test to see if it is odd. For odd we need the negative, so we will manufacture by factoring out a negative sign. So we have to have a negative sign there. And so that will be 2x cubed inside minus 5x minus 2. Now we compare this, the inside, with the original function. 2x cubed, that's good. Negative 5x, that's good. 2 and negative 2. That is not. So inside is not the original function. So this is not the original function inside the parentheses, meaning that it is not negative f of x. And because of that, it is not odd, meaning this function is neither odd nor even. Next, we have 2x squared plus 3. So as always, the definition, whether it's odd or even, we start with f of negative x. And that's exactly where we start with. We just need to replace negative x into x. So that would be 2x squared, because negative square, 2 negative sign become positive, and then plus 3. Compared to the original function, it is exactly the same as the original function. So this one is even. We could have a rational function like this as well. Still do the same thing. F of negative x. So we put negative x into x. Now when we look at this, we'll see at the bottom negative square, so that would be positive x squared, so 2x squared plus 5. On the top we have 3 negative signs, and then one more, so it will be 4 negative sign will turn to positive. Now obviously they're not the same, we're missing a negative sign. So because it is not equal to the original function, this one is not even. Next, we have to manufacture a negative sign. If we put the negative sign out, we're going to have negative 4x cubed, because when distribute the negative inside, that should be positive. So we have, when we factor out the negative sign, we have this. This is exactly the original function. So inside the parentheses or the bracket, this is the original function. So altogether, this is equal to f of negative x equal to negative f of x. So that's why this function is odd. And that's how we determine a function is even, odd, or neither using the definition. Those are the definitions.